Modern aircraft engines have over 5,000 sensors monitoring every microsecond of operation. But there's one system most passengers never hear about that's keeping them safe: the full authority digital engine control. Today we're exploring how this technological marvel prevents catastrophic failures while juggling thousands of calculations per second.
You know what's fascinating about Fadec? It's essentially replaced an entire team of flight engineers who used to manually monitor these complex systems. Now it's all handled by sophisticated computers making split-second decisions.
And here's something that'll blow your mind. When the Fadec detects even the slightest abnormality in engine performance, it can make up to 8,000 adjustments per second to maintain optimal operation. It's constantly balancing power, fuel efficiency, and safety parameters.
Hold on, 8,000 adjustments per second. That's incredible. How does it manage all those variables simultaneously?
Well, think of it like an orchestra conductor, but instead of musicians, it's coordinating fuel flow, engine temperature, blade positions, and something really fascinating called fan flutter protection. When the aircraft is on the ground at low speeds, it prevents the engine from stabilizing between 60% to 74% of N1 speed to avoid dangerous vibrations.
So that explains why pilots sometimes notice unusual engine responses during ground operations?
Exactly right. And here's where it gets even more interesting. The system has three distinct idle modes, each serving a specific purpose. The approach idle mode is particularly clever because it keeps the engine in a state where it can quickly spool up if pilots need to abort a landing.
Hmm, that makes me wonder about takeoff procedures. How does FADEC handle different power requirements?
Oh man, this is where Fadec really shines. It has this brilliant feature called flexible takeoff, where pilots can input a higher temperature than actual conditions. The system then reduces engine power accordingly, saving fuel and reducing wear when maximum thrust isn't needed. But, and this is crucial, pilots can instantly access full power by pushing the thrust levers forward to toga position.
That's quite a safety net. What other protections does it provide?
Well, one of the most impressive is the automatic toga function. If pilots haven't set proper takeoff power, the system first warns them with an engine thrust levers not set alert. They have 5 seconds to correct it, or Fadec automatically applies maximum available thrust. It's like having a digital guardian angel watching over every takeoff.
You know what really strikes me about all this? Most passengers have no idea this level of sophistication exists right outside their window.
And there's even more to it. The system manages fuel recirculation based on multiple factors: engine oil temperature, fuel system configuration, and flight phase. It's also monitoring for potential issues like engine stalls, excessive vibration, and overspeed conditions, all while transmitting a constant stream of data to the cockpit displays.
That's remarkable how it balances all these parameters while maintaining safety margins.
Speaking of safety margins, let me tell you about the engine start sequence. FADEC controls multiple critical parameters simultaneously: the start valve, high-pressure fuel valve, fuel flow, and ignition. If anything starts trending wrong, it can immediately abort and recycle the start sequence.
So it's basically like having the world's most attentive engineer watching every aspect of the engine.
That's a perfect analogy. And what's truly remarkable is how all these complex functions happen in milliseconds, constantly adapting to changing conditions. But here's the key thing. While it provides all these automated protections and optimizations, it never takes away the pilot's ability to control the engines when needed.
That really does sound like the perfect balance between automation and human control.
And that's exactly what makes modern aviation so safe and efficient. FedEx represents the culmination of decades of aerospace engineering, creating a system that can process more information than a human ever could, while still maintaining that crucial element of pilot authority. It's truly one of aviation's unsung heroes,